everyone. In this video, let us solve this equation. So we have 2 raised to power t is equal to t raised to power 32. And here, we have to solve for all the possible values of t that will satisfy this given equation. So t is equal to question mark. Now to solve for t, solution, right, we are given 2 raised to power t is equal to t raised to power 32. Now, firstly, we are going to multiply the both sides of the equation by power 1 over t. So we're going to have in brackets 2 raised to power t, then multiplied by power 1 over t is equal to, we have t power of 32, then multiplied by power 1 over t. At this junction, we're going to apply one of the rule of indices, that if you have in brackets a raised to power n, power of m, this equals a raised to power n will multiply m, you have n times m. So applying this principle right to this, we're going to have 2 raised to power t, then times 1 over t is equal to t raised to power 32, then times 1 over t. With this, we have it as 2 raised to power t times 1 is t, all over t is equal to t raised to power 32 times 1 is 32, then all over t. Now, t will divide t, you have 1, so 2 raised to power 1 is equal to t raised to power 32 all over t, right? So 2 raised to power 1 is 2, which equals t raised to power 32 all over t. So with this, right, the next thing now is to eliminate this 32. And to remove 32 from here, we multiply the both sides of the equation by power 1 over 32. So we're going to have 2 raised to power 1 over 32 is equal to, in brackets, we have t raised to power 32 over t, right? Then multiplied by power 1 over 32. Good. So with this, we have 2 raised to power 1 over 32 equals t raised to power. Now, applying the same principle right to this, we have it as 32 over t times 1 over 32, such that 2 raised to power 1 over 32 is equal to t, then 32 will count to 32, we have 1 over t, so power 1 over t. Now with this, looking at this, what you have is that, okay, power t right here, the base, this right here is the base, and this is the denominator, right? Is the denominator. So looking at the base and the denominator power, as you can see, they are both equal, right? So we are going to make it that, okay, the base right here should also equal to the denominator power right here. So how do you go about it? Well, to go about it, we'll make use of the equivalence fraction. Now, what do I mean by equivalence fraction? Now, let's say you have 1 over 2. Now, 1 over 2 can be written as 2 over 4, because 2 will divide 4, you have 1 over 2 back. Okay, same thing also if you have 1 over 32, it can be written as 2 over 64, right? Just that 2 will divide 64, you have 1 over 32, right? So in replace of 1 over 32 right here as the power, we can impute 2 over 64 to replace 1 over 32. So we're going to have 2 raised to power 2 over 64, which equals t raised to power 1 over t. Now with this, right, if we factorize out 2 from here, we're going to have 2 raised to power 2 times 1 over 64, right, is equal to t raised to power 1 over t. Now at this junction, we are also going to apply a principle of indices, that if you have a raised to power c times d, this equals, in brackets, a raised to power c, then power of d. Applying this principle right here, we're going to have, in brackets, 2 raised to power 2, then power of 1 over 64, which equals t raised to power 1 over t. Now with this equals, right, 2 power of 2 is 4, right, all raised to power 1 over 64, and this equals t raised to power 1 over t. At this junction, right, now the base right here is not still equal to the denominator of the power, and that is the goal, that we must make the base right here to equal the denominator power, so that we can then compare the exponent as we have right here, so that the base is equal to the denominator power. So now to then solve it, right, we're also going to make use of the equivalence fraction. Now 1 over 64 can be written as 2 over 128, right, shows that in replace of 1 over 64, we can put in 2 over 128. So right here, we have in bracket 4, all raised to power 1 over 64, we can put in 2 over 128, which equals t raised to power 1 over t. Also applying this principle to this, right, this becomes, okay, but before then, we have 4. Factorize out 2 from here, we have 2 times 1 over 128 is equal to t raised to power 1 over t, such that we can then apply this principle to this, and this then becomes in bracket 4 raised to power 2 all raised to power 1 over 128. This equals t raised to power 1 over t. Now with this, right, now 4 squared is 16, right? All raised to power 1 over 128, which equals t raised to power 1 over t. At this junction, looking at this base right here, which is 16, is not still equal to the denominator power, which is 128. And the goal is to make the base to equal the denominator power. So, still working with the equivalent fraction, right? 1 over 128 can be expressed in the form of 2 over 256. So in replace of 1 over 1 2, we can bring in, so again, so in replace of 1 over 128, you can bring in 2 over 256, right? So in bracket 16 all raised to power 2 over 256 is equal to t all raised to power 1 over t. Now with this, okay, we can factorize out 2 from here. We then have in bracket 16 all raised to power 2 times 1 over 256 is equal to t raised to power 1 over t. Now I'm applying the principle that if you have a raised to power c times d, this equals in bracket a raised to power c, then power of d. So applying this principle to this right here, what we have is 16 all raised to power 2, then power of 1 over 256, right? Which equals t raised to power 1 over t. At this junction, what we have is 16 squared is 256, right? All raised to power 1 over 256 equals t raised to power 1 over t. And boom, we have gotten it. We have made the base right here, right, to equal the denominator power. So such that we can then compare the exponents. Now, if you have a raised to power c, which equals a raised to power d, since the base are equal, we can have it that c is equal to d. Now, with this, 1 over 256 is equal to 1 over t by comparing the exponents. At this junction, to then solve for t, simply cross multiply. T times 1 is t is equal to 256 times 1 is 256. And with this, we've gotten the value of t. But before we go, let's confirm, let's check if the value of t that we got as 256 is truly the correct value for the equation. So let's check. The equation is 2 raised to power t, which equals t raised to power 32. Now the value of t is 256, right? So 2 raised to power 256 is equal to t. Now it's becoming 256. So in bracket 256 all raised to power 32, right? So with this 256 right here is equal to 2 raised to power 8. Because now, okay, let's say we have 256. 256 is 16 times 16, and 16 is 2 raised to power 4. Then times 16 also 2 raised to power 4. Applying the law of indices, we have the same base. You pick one, then you sum up the powers, 4 plus 4. Now 2 raised to power 4 plus 4 is 8. So in other words, 256 is 2 raised to power 8. So we're going to have 2 raised to power 256 is equal to 2 raised to power 8, right? All power of 32, right? Such that with this, okay, applying the principle of indices, that if you have a raised to power n, power of m, this equals a raised to power n times m. Applying this principle right to this, we have 2 raised to power 256 is equal to 2 raised to power 8 times 32. And 2 raised to power 256 is equal to 2 raised to power 8 times 32 is equal to 256. So therefore, the value of t that we got is the correct value that will satisfy the given equation. Okay, so I hope you've learned one or two. Don't forget to like the video, share the video to your friend, please subscribe, and also please you can feel free to ask your question in the comment section. Thanks for watching. See you in the next video.